Hi, today we'll talk about two different type of circuits, series and parallel, and we will compare them and see how they different. Okay, so I will put very simple materials into circuits, two resistors, a battery, and I will use also symbols for ammeters and voltmeters. And I will connect them differently, so you will see the difference. So the first way, I will just put two resistors next to each other. The first one and the second one. And I will label them R1 and R2. If you look at the reference table, you can see the symbols. Okay, it's right here. Symbols for circuits. So resistors, I use two of them. Voltmeters I will use, ammeters, and a battery. Okay. So I just connected, these are connected wires, and now I will connect them to a source of electrical energy, a battery, and as you remember, the short line is negative, the long one is positive. Okay, and if it's closed circuit, electrons start moving through resistors from negative terminal attracting to the positive terminal. So that's the flow of electrons in the circuit, clockwise in this case. Okay, so if you think about electrons, they need to go to the first resistor and then they will continue moving through the second resistor. There's only one path for the electrons to flow, no other choices. So this circuit has one path for electrons to flow. Okay, I can connect two resistors a little bit different. I will start with the source of electrical energy, battery, and then I will connect the first resistor, R1, and then on the top I will connect the second one, R2. Now you can see that these two connections are completely different. Let's think what will happen to electrons. Both of them are closed circuits, right? Closed loops. So this is negative, this is positive terminal. So electrons will start moving, right, from negative toward the positive. Now what will happen at this point? At this point, electrons have two choices, right? That point is called junction. So part of the electrons will move here, and part of the electrons will move up to the second one. Just looking ahead, think, which way electrons will prefer to move? Through the higher resistance or through the lower resistance? Okay, we will discuss that later. So what will happen? The flow of electrons will split in two, going through the first resistor, and part of the electrons will flow through the second one. As they flow through the resistors on the opposite side, you can see that electrons will combine and go back to the positive terminal. So that's the main difference between these two connections. In the first one, we have only one path for electrons. On the second one, you have two different paths. Okay? So when you have more than one path. Okay, and these are two different connections. I can add the third one if I want the fourth one. I can connect as many as I want, and electron flow will split, or I can keep adding here electrons and they will still have only one path to flow. So this connection, because resistors are connected one after another, I can keep going that way. It's called series circuit. And this one has more than one path for electrons to travel, and it looks like it's parallel position for the resistors. It's called parallel circuit. So that's the main difference. One path, series connection, more than one path, it's called parallel circuit. Okay, so every circuit, electrical circuit, need to be described by current, potential difference, sometimes it's called voltage, sometimes it's called potential drop. Okay, and of course resistance. Now if you think about series connection, as electrons flow, they will experience like first resistance first and then the second one. So if you think about the rule which we can use for equivalent resistance, what we call equivalent resistance, it will look like sum. So now I will write down just the law of circuits, and I will do the series first. Circuits. So the total resistance of 2 or 3 or more resistors, total, in this chapter is called equivalent. Equivalent means it's equals to the total, and it equals R1 plus R2 plus R3. If I keep adding 4, 5, 6, I need to keep the resistance adding here, the resistors adding here. So if you look over here, like the path of the flow of charges increases as I keep adding resistors. It's like longer equivalent resistance. It's different story here for the parallel connection. Now what about the current? Since it's only one path through the charges, that means it would be only one current as well, right? Only one current. So if I want to find out what is the total current, it will be equal to current flowing through R1, and it will be equal current through R2, or if I have more R3, I can add R3 here, or I can add another resistor over here. So the rule for the current, which is total current, will be equal total that goes through the first one equals current that goes through the second one, through the third one, and so far if I keep adding them. Now I need to find out what is the rule for potential difference. Let's say that potential difference of this device is 15 volts. That would be my total V. So what will happen here? Electrons need to go through this resistor, first one, and then through the second one. So if I'm looking at these 3 points, okay, 1, 2, and 3, there would be potential difference between points 1 and 2, which is potential drop or potential difference across the first resistor, and there would be potential difference between points 2 and 3, which is potential difference for the or potential drop for the second. So there would be V1 potential difference across the first resistor, and then potential difference V2 across the second. And what it will add up to? It will add up to the total. So the potential difference will not split evenly. We will talk about it later. It will depend on amount of resistance. So higher resistance will require higher potential drop because it's more difficult for electrons to flow. So the rule for the potential difference will be total, that's total, equals V1 plus V2 plus V3, and so far if I have more. So again, to find total or equivalent resistance for series circuit, we just add resistors simply to find total or equivalent. To find total current, we just keep in mind, since there's only one path, current will be the same. So it's total current, it's the same. Potential difference or potential drop total will be equal potential drop of across the first plus the second plus the third and so far. So you add the individual potential differences to find the total. Now what about parallel? For parallel circuit, it would be a slightly different picture. Why? Because there's more than one path for the charges. If you think about total current, so which flows over here, for example, you're supposed to split it into different ways. So current that goes through first one we will call I1. Current that flows through the second one would be I2. They're not equal usually, but they can be equal if these two resistors are the same. But to find the total between them, since the total splits two different ways in this diagram, you need to add. So I total, right, for the parallel will be equal the first current through the first resistor plus I2 plus I3 and plus so far if you have more. Okay, that's the difference. Here current is the same for series because it's only one path. Here we have multiple paths for charges, and to find total we just simply add them. What about potential difference? It also would be completely different. Now I will give you the same example. Let's say potential difference here across the device battery is 15 volts. Now if you look at these 2 points, potential drop between them 15 volts. If we're looking at these 2 points across the first resistor, it would be also 15 volts because it's the same 2 points inside the electric field that produces this current right now. And if you look across these 2 points, potential difference would be exactly the same. So it looks like position of each resistor here is the same in terms of electric field. That's why the rule for potential difference, so to find total here, right, we need simply say that V1 equals V2 equals V3 and so far. So a rule for R will be equivalent resistance, also would be completely different. Why? Do you see? All electrons are not supposed to flow through all of them. So part of electrons go through R1, I'm sorry. Part of electrons go through R2 in this case. But we're here in series connection. All electrons supposed to go through the first one and through the second one. That's why we cannot simply add R1 and R2 to find equivalent resistance. In opposite, electrons split, and it's much easier for them to move. So I will show you the equation first. Equation is a little bit complicated. So what do we call 1 over something? It's called reciprocal, right? So reciprocal of R equivalent equals 1 over R1, or reciprocal of first resistors, plus 1 over R2, plus 1 over R3. If you have more, you will just keep adding. So to find resistance here, we simply add resistance R1 plus R2 plus R3 and so forth. To find here equivalent resistance, we first find a reciprocal. I will show you how we can write down a reciprocal in other way. It's R equivalent to the -1. Is it true that that's 1 over R equivalent? It equals R1, reciprocal of R1, plus reciprocal or R2, plus reciprocal of R3, and so far. So how to use this equation, I will show you in the next video. Okay, today we will just discussing the regular the equations that we actually can use for series and parallel circuits. So if you see the rules here absolutely different. So current remains here the same. How would you remember that current for series remains the same? It's because in series we have only one path, so all electrons go through the same way. How would you remember that current here is supposed to be added to find total? We need to add the individual currents. Current, total current splits in different ways, going through each resistor. Now, potential difference here is the sum of individual, because they are placed next to each other in electric field. While here, they just equal to each other, because every 2 points across battery, across the first resistor and second, and if you have third, fourth, and so far, it would be exactly the same amount. Now, if you look at the reference table, I'll show you the reference table now. Right here, reference table. You have series circuits and you have parallel circuits. And you don't need to memorize. What you need to memorize, that this one is one path, right, for charges, and parallel circuits, multiple path. Okay, multiple paths for charges. That's the difference. If you remember this, then in the question they usually state what kind of circuit you have, you know what equations to use. But that's not all. That's not all. What we can use for both, besides these equations, for both circuits, we can use what we called before and we discussed Ohm's law. That's the Ohm's law in your reference table. Resistance equals potential difference over current, okay, V over I. That's Ohm's law. We discussed that, we did the questions, you watched the video before on Ohm's law. So how can we apply Ohm's law for both of these type of circuits? So you're supposed to remember one thing. So if you're looking for R equivalent, right? If you're looking for R equivalent, you can use it for R equivalent. But what V we should take? V total, V1, V2, V3, or which one? If it's equivalent, it makes sense to say that it's supposed to be total. Okay? And which I should we take? We're supposed to take I total. Just in this case, I total is the same as I1, I2, and I3. Okay? What if you're looking for R1? Which V and I you need to take? 1 over V1 over I1. What if you're looking for R2? You can use a V2 over I2. What if you're looking for R3? A V3 over I3. So in these equations you have three quantities. So you always can use this equation to find R1, for example, or V1 or I1, whatever is missing. So for each of these sets of equations, series and parallel, you can use also Ohm's law. But what do you need to keep in mind? That R, V, and I is supposed to correspond to the same resistor or resistance, or if it's equivalent, that's supposed to be equivalent, total, total. So if you keep this in mind, it would be much easier to solve the problems. So we're not going to practice today, but in the next video I'll show you how to apply these laws to use these equations and solve questions for different type of circuits.